beginning of the study guide, we mentioned John Dalton, and he had some theories about early atomic structure. One of those theories was that atoms of the same element are always the same, which even at the time we kind of disputed that there are these things called isotopes. Isotopes are atoms of the same element, but they have different numbers of neutrons, or sometimes you might hear it worded as different mass, because we mentioned that the neutrons really just add mass and stability to the nucleus. If you didn't have neutrons, you would have a very unstable nucleus. The nucleus would be entirely positive protons and like charges repel. Okay, so there are a few different ways that you could see an isotope noted. The symbols for an isotope could change a little bit. Here we've got hydrogen 1, the symbol H with a little superscript 1. I see that quite a bit. Actually, I more often see it kind of like this. Hydrogen 1, 1. On top, this would be the atomic mass. And then on bottom is the atomic number. Now, I guess in a sense the atomic number is kind of irrelevant if they're already giving us the symbol, because we can look on the periodic table and look up hydrogen and tell that its atomic number is 1. But often they'll give you both the atomic mass and the atomic number. So the other ones could also be written like this: hydrogen 2, 1. Hydrogen 3, 1. These are all different forms of hydrogen. They have one proton in the nucleus. The atomic number is 1. The difference is the atomic mass. Deuterium is a form of hydrogen with a mass of 2. That means there's one proton and one neutron. Hydrogen mass 1 is only a proton. There's no neutrons. It's the simplest atom. And then finally, tritium is an even heavier form of hydrogen with a mass 3. So if the atomic number is 1, that means there's one proton. There must be 2 neutrons to get a mass number totaling 3. Another option, how you might see this symbolized, they might write the name hydrogen dash 1, or hydrogen dash 2, hydrogen dash 3. So they're telling me that it's hydrogen, and if I know it's hydrogen, I can go to a periodic table and look up the atomic number to be 1. But then they're giving me the atomic mass following the name. And again, you could also see this as like H1, H2, or H3. And same thing, this number at the end is the mass. So just different ways of showing an isotope. Different forms of the same element. And the real difference comes from the nucleus. The number of neutrons will change the mass slightly. So if we look to this big chart, which we kind of started in the last video, and hopefully you had a chance to try some of those other elements. So you can check those over if you need to. You could pause the video here, check over magnesium and uranium and some of these other elements to see if you had the right atomic number, atomic mass, protons, neutrons, and electrons. Now, one note. All periodic tables will be a little bit different when it comes to the atomic mass. Now, usually, if we all round it to the same whole number, we'll all have the same atomic mass in that column. If by chance you had kind of a funky periodic table that gave a different amount of decimal spots, and then for some reason you rounded, I don't know, maybe you rounded uranium a little different, that's okay. For tests and quizzes, we'll all use the same periodic table, so we'll have the exact same answers. as long as you got it right. If you're doing homework problems, yeah, your periodic table might be just slightly different than someone else. But again, if in that atomic mass column we all round to the nearest whole number, we should be looking at the same answers. So the hydrogen and carbon ones that we skipped, those are isotopes. And I mean, for any element, there are multiple isotopes. It's just that hydrogen and carbon have some kind of common isotopes. So we'll look at these in particular. Hydrogen on the periodic table is element number 1. So I could go through all of these and put the atomic number as 1. If the atomic number is 1, that means there's 1 proton. So while I'm at it, they will all have a proton. And as long as they're all neutral atoms, they will all have 1 electron. The difference comes in the mass. And normally we said look up the mass on the periodic table and round it to the nearest whole number. In this case, when they give you these numbers at the end, they're referring to a specific isotope with a specific mass. The periodic table will give you the mass of the most common or the most abundant isotope, which we'll talk about in a minute. But there are other isotopes. They're usually just a little less stable or uncommon. But here they want me to specifically refer to the isotope with a mass 1, mass 2, mass 3. Well, that's easy. You don't even have to look it up. The number after the name is the mass that they want you to refer to. So now here's the difference. Look at hydrogen 1. 1 proton, mass of 1. There are no neutrons. It's a really simple atom. Just 1 proton in the nucleus, 1 electron in the electron cloud, that's it. It's neutral. Hydrogen mass 2 will finally have 1 neutron. The protons plus the neutrons need to add up to the mass. So it's a very simple atom as well. 1 proton, 1 neutron, 1 electron. And finally, hydrogen 3 has 2 neutrons. So that I get a mass number of 3 when I add protons plus neutrons. There. So these isotopes aren't crazy. Maybe they're even a little easier. Carbon has 3 common isotopes. Carbon on my periodic table is element number 6. Atomic number is 6. They're both carbon. They have the same number of protons, 6. The number of protons can be used to kind of identify the element. There's no other element with 6 protons. And again, if they're neutral atoms, there will be 6 negative electrons. The 2 isotopes that we're looking at here are mass 12 and mass 13. So carbon 12 must have 6 neutrons, so that the neutrons plus the protons add up to 12. The only difference, carbon 13 has 1 extra neutron. That's not so bad. Second, hopefully you can use your periodic table to look up these protons, neutrons, electrons, atomic number, and atomic mass. In the next video, we'll look a little bit more specifically at how we get those different atomic mass numbers for our isotopes.